Okay, so in this video we are looking at Pythagoras' theorem. Remember, you're going to need your calculator handy for this one, and at any point you can pause and have a go any of the questions. Then when you press play, check your answers with my workings. Pythagoras' theorem is all about right-angled triangles. You can find either the long or short side of a right-angled triangle by following 3 simple steps. The long side of a right-angled triangle has a very special name, and it's called the hypotenuse. And if you're ever in doubt as whether you're looking at the hypotenuse is always opposite the right angle. So in this question, we're trying to find the hypotenuse. The hypotenuse is what I always refer to as the long side. The other 2 sides are both shorter. They're not the same length, but these 2 sides will always be shorter than the hypotenuse. The hypotenuse is what we call the long one. Pythagoras discovered that there's a relationship between the 3 sides of a right-angled triangle, and it's only true for a right-angled triangle. It doesn't work in any other type of triangle. But he discovered that if he squares the length of the sides of a right-angled triangle, the 2 short sides, when squared and added together, gave him the same total as the long side squared. So Pythagoras discovered that if he knew the length of the 2 short sides and he squared them and added together, the answer he got was the same as the length of the hypotenuse squared. So this gave him enough information so that without drawing triangles, him and everybody since then has been able to find the long side and short sides of a right-angled triangle using Pythagoras' theorem. So I remember it with 3 simple steps. S for square, because we always square the numbers. Either A, if we're using Pythagoras in this format to find the long side, or S, I'll show you that in a minute, for the short side. And then the final step is to square root, because to get the actual length of the hypotenuse, we've got to undo the fact that this is c squared. This is the hypotenuse squared, and not the hypotenuse itself. So on my calculator, which is just here beside the screen, I'm going to do a calculation. I'll first of all write it down. I've got the 2 short sides, 15 and 8. So here I am, I've squared them. This is going to be an addition sum, so it's ready to type into my calculator. 15 squared plus 8 squared comes to a total of 289. This is not the length of the hypotenuse. This hypotenuse is not 289 centimetres long. Clearly it is nowhere near that. The final step is SR for square root. The square root symbol on your calculator is right next door to the square key, and it is a tick-like symbol with a box for you to put in your value. So I will press that key before typing in 289, and then when I press equals, I'll get an answer of 17, telling me that AB, the hypotenuse in this question, is 17 centimetres long and is, as mentioned, the longest side of the triangle. So this is when I was finding the long side of a triangle. And to find the long side of the triangle, I square, I add, and then I square root. In question 2 here, I've actually got the hypotenuse. I've got the longest side of the triangle with information already on it. I must find BC, which is one of the shorter sides. So comparing my method here from question 1, instead of S, A, SR, following the Pythagoras said add them together to get the hypotenuse, I'm going to have to think of this in a slightly different way. So here goes. Pythagoras did say if I square the 2 short sides and add them together, I'll get the hypotenuse squared. But if it's one of these short sides, maybe this one or this one, that I actually want to find, then I don't want to add them together. I actually wanted to figure out what the difference is between the hypotenuse and the side that we know. So if it was a squared that I was trying to find, I'd want to know the difference between the hypotenuse squared and the other side squared, because that difference must be what a squared brought to the equation. In my revision, instead of having SASR, I remember it as square them. This time, for a short side, subtract them, and then square root. So the two are quite similar. For the long side, we square, add square root, and then for the short side, we square, subtract square root. So what does it look like in this calculation? So here are my two sides, the longest one and the shorter one. Here they are squared, ready for the calculator. Subtract. And then on my calculator, when I type in this calculation, using the squaring key gives me 364. This does not mean the short side is 364. This means that the short side squared is 364. And that final step of square root, I square root that 364, and I'm going to get 19.07878, and it carries on going. Here in the question it says give your answer correct to one decimal place. Correct to one decimal place, that is 19.1 centimetres. In question 3 now, press pause and decide before I show you whether you're doing square add square root or square subtract square root, by deciding whether you're finding the long side or one of the shorter ones. Okay, did you get it right? Because we're trying to find this hypotenuse, so we're trying to find a long side. Yeah, it's back to the square add square root, because it's following the very first example. So I square them, I add them, I get 149, and then the last step, I square root. Square root in the 149 gives me 12.2. So this side is 12.2, and then for the perimeter that they've asked for, the perimeter will be all three sides added together, which comes to a grand total of 29.2 centimetres. Long or short, you decide, and then you can decide if we're going to square add square root or if we're going to square subtract square root. Okay, in this question we are looking to find the length of AB. This will be the hypotenuse, so we're going to square add square root. For a long side is square add. For the short side, it was square then subtract. Here are my values, squared with my adding up. 24 squared plus 7 squared comes to a total of 625. Final step, square root of 625 gives me 25 centimetres. So AB 25 centimetres long. Question 5, you decide square, add, square root, or square, subtract, square root. Okay, for this question we're actually finding this short side here, and when you're finding a short side you're going to subtract. So here are my numbers squared, here's my subtraction. 14 squared take away 10 squared is 96, and here is my square root. (9.797). I'm actually going to use that as being 9.8 centimetres. When I add 9.8 centimetres to the diagram this time, the question actually wants me to find the area of the triangle. To find the area of the triangle, I need to do half the base times the height, and now that I know that base is 9.8, I have all the information that I need. Half the base times the height, so a half multiplied by 9.8 multiplied by 10, and the area of this triangle is 49 centimetres squared. Question 6. Before I even read the question, is it going to be a long or a short side? If it's a long side, square add square root. If it's a short side, square subtract square root. 3 steps. Very similar, just a tweak in the middle if you're finding a long or short side. A 4 metre ladder is placed against a vertical wall. The base of the ladder is 1.5 metres from the base of the wall. Work out how far the ladder reaches up the wall. A numeracy question still based on Pythagoras, still expecting us to decide whether it's the long or short. Well, the hypotenuse is this 4 metres here. So the side that we're trying to find is a short side. So here are my values squared. Step 1. This is a subtraction. Step 2. 4 squared take away 1.5 squared gives me a value of 13.75. The square root of 13.75 for my final step, 3.70809. So I'm going to round this to be 3.7. They've used 1 decimal place, so that's how it looks good to me. And it's going to be 3.7 metres. Question 7. Okay, I kept really quiet through all that one. Could you follow what I was thinking even though I didn't say it? So in this question we had a mixture of units. So here I changed my 2 metres to 200 centimetres as I can't use metres and centimetres in the same calculation. I knew I was finding a short side, and if I'm finding a short side I'm going to be subtracting. And then here is where I picked up my calculator. Squared, subtract, and then I square root. 1 decimal place answer, and my answer has been rounded to 1 decimal place. But don't forget, this is in centimetres. I nearly forgot myself. So to change that to metres, I need to change it to 1.9. So this is in centimetres, 1.936 metres. And they only won 1 decimal place in the final answer. So my final answer, a bit lost there. My final answer is that 1.9. Last question in this revision. So we have another numeracy question. The distance from a point on the ground to the base of the tree is 18 metres. So that 18 metres is going to start right here. The distance from a point on the ground to the top of the tree is 20 metres. That's going to stop right at the top. Calculate the height of the tree. Well, sometimes it's a bit difficult in a diagram to see what you're dealing with. So take out the picture of the tree and make it into a right angle triangle that you're used to seeing now. 18 metres across the bottom, 20 metres here, which would be the hypotenuse. So I'm finding a short side. H for height, and that's a short side of the right angle triangle. Here are my values squared. This is a subtraction because we're finding the short side. Squared subtraction. On my calculator, again, answer of 76. Square root of 76 for the last step. I get 8.71779 ... In the question, give your answer correct to 1 decimal place. 8.7. So this tree is 8.7 metres tall. Okay, that's the last question for the Pythagoras booklet, to just run through the basics. If you want any more revision of Pythagoras, or if you want any other videos uploaded, then just make sure you talk to your maths teacher and we can make sure that you've got them online as soon as possible.